we're off. I wanted just to return to integrating using the formula sheet. You would have noticed, some of you from my objective, I want to get on to integrating using the identities today, but I think we sort of didn't have enough time at the end of the lesson to talk about the formula sheet. So I've just got here page 6, the bottom of page 6 on the formula sheet. So I'm going to leave that up there rather than sort of giving out formula sheets. I just wanted to pick out 3 of these, and of course there are another set at the top of page 7, but I'm just picking out 3 of these and just being absolutely clear on how we can use them. So the first one I want to pick out is this one, and remember, when we're integrating at the bottom of page 6, we're going that way. When we are integrating at the top of page 7, we're going that way. Why they choose to set it out that way in such a confusing way, I have no idea. There we go. That's the way it goes. There you go. So with that in mind, my question first is, what do we do if we've got no value at the front there? So what if we are being asked to integrate something like sec of 2x tan 2x? Well, if there was a 2 out the front here, then we know the answer would just be sec 2x. And we haven't got to understand where this comes from. This is provided for us. So if I've got a 2, a 2, a 2 there, that's what the answer would be. Without a 2 there, this is half of that. So this is just divided by 2. Okay? So just see if you can tell me what you get if just see if you can write down what that's going to be using a similar sort of thing. Think, what if there was a half there? Take away the half. What does that make the answer? We're just going to do 3 of these where we just try and unpick how we use these formula book identities. So if there was a half there, that would be the answer. If we take away that half, we've divided it by a half. So the answer needs to be divided by a half, which is the same, hopefully you remember, as multiplying by 2. So that would be the answer to that one there. Okay? The second one is, am I going to be able to do this? Yes, look at that. Was that one there? And it's, unsurprisingly, very, very similar. Remember, integrating at the bottom of page 6, we're going from right to left. So just again, see if you can tell me what cosec squared x becomes, and then what about cosec squared 3x? What would those become if we integrated them using that particular expression? There's no number out the front, and this time, remember, we're expecting it to be a minus number. So this is a 1x here. So if there was a minus 1 out the front, the answer would be cot x. There's no minus there. So we need to divide this by minus 1. So that's how that goes. And if there was a minus 3 here, then the answer would be cot 3x. But there's not. We've divided it by minus 3, so we need to divide this by minus 3, which I would probably write like that, but you could also write it cos cot 3x. And forgive me if I'm over-labouring the point, but it would be a shame if we missed out on easy marks. So the third one, another one with negative values in there. So again, see if you can, using that one, see if you can integrate for me. That for me. That for me. And remember again, this is one with a negative. Had a minus, it would be that, but without the minus, it needs to be divided by minus 1. If it had a minus 2, then it would be cosec 2x. It hasn't got the minus 2, so we need to divide it by minus 2, which I would probably write like that, but you could write it as minus a half, or you could leave the minus 2 on the bottom, it doesn't actually make a difference. And if this had minus a half there, then it would be cosec a half x. Hasn't got a minus half, so I've got to divide it by minus a half, which is the same as multiplying it by minus 2. And a similar thing applies on the top page 7. It's just you're going from left to right with the integrate there. And while we're down here, this is the quotient rule. So they do give you the quotient rule. I don't like the way they give it to you, but remember when we use the quotient rule to divide one thing divided by another, I tend to talk about u and v. They're calling it f of x and g of x. So you've got that multiplied by that minus that multiplied by that divided by that squared. So the quotient rule is on the formula sheet. And of course, it's very similar to the product rule. It's just with the product rule, there's no division, it's a plus. So, if you struggle, it tends to be something people remember, but if you struggle to remember the quotient rule and the product rule, then there is that sort of hint at the bottom of page 6 of the formula book. Okie dokie, right, so I want to talk about using the identities to integrate. And this is really useful because it's a sort of timely reminder of using the identity. So the first one we'll whiz through is there's only one identity for sine 2x. It's that one. And you know, unusually that's something I actually remember. But don't forget, if you can't remember it, top of page 6 of the formula book, you've got the sine a plus b formula that you can just make a and b equal to x, and you can get that. And so that means if I'm asked to integrate that, that's the same as being asked to integrate that. Now just be clear, this isn't like the bottom of page 6. This isn't what you get when you integrate sine 2x. This is the same as this. So go on, see if you can integrate sine 2x. Let me remind you about my little cycle. Sine becomes cos, cos becomes minus sine becomes minus cos. When you differentiate, today though we are going the other way around, aren't we? We're integrating. Sine becomes minus cos. Sine 2x becomes minus cos 2x, divided by what you get when you differentiate the brackets. Didn't put in brackets, but divided by 2. Okay, see if you can write the two Pythagorean identities we get by starting with sine squared plus cos squared is 1 and dividing everything by sine squared, or dividing everything by cos squared. These give us those identities that involve cot and sec and cosec and tan. See if you can recall those two identities. I don't remember these ones, genuinely, so I always have to do this. And then we'll use those to integrate. So if I was asked to integrate tan squared, my first place would be, the formula book. And I'd have a look in the formula book and I'd say, right, can I see a way of integrating tan squared in the formula book? I can't. So my second question would be identities. And I'm hoping that you can rearrange this identity as tan squared equals. You can therefore replace tan squared with something that you can integrate, and therefore integrate it. Go on, see if you can puzzle that one out for me. There's a fairly similar process for integrating cot squared. but it's not helpful in this particular case. That's actually, sorry, it will be helpful down here. Sorry. Yeah. Just realised I've given out my last formula. So tan squared is sec squared minus 1, and sec squared I can integrate, it becomes tan, not tan squared. Do you remember, tan doesn't get to join in with the circle party here, but tan, when you differentiate it, becomes sec squared, so when you integrate sec squared you get tan, so that becomes that. And there's a similar process for cot squared. Cot squared is the same as cosec squared minus 1. And cosec squared is on the formula sheet. It becomes cot. Okay, so we've used our sine. Sorry, I made a mistake.
Is it minus cot?
Oh.
Am I just making that up?
You are absolutely correct. Thank you very much. Thank you. Yeah. Minus cosec becomes cot, so cosec becomes minus cot. Thank you very much. Okay, so we've used the sine 2x identity. There's only one way we can use that. We've used our Pythagorean identities, and they crop up quite a lot. So watch out for those. So I'm sort of hoping you guess where we're going now. And that's the cos 2x identities, of which there are many. So if I remind you about the sort of the first one, that's the one you get if you take the cos A plus B formula at the top of page 6 on the formula book and make A and B both x. So see if you can rewrite that in the form that's only got coses and the form that's only got sines. So this is a good sort of revision of those identities, isn't it? Can you write it in the way that's got coses and the way that's got sines? Okay, now I just want to park that for the moment, and the reason for this will become clear. I just want to talk briefly about differentiating. So, can I ask you to see if you can remember how to differentiate, be clear, differentiate those two things, okay? You may remember we need to rewrite this in as what it actually is before we differentiate it. Have a go. Just see if you can differentiate that. So remember, when you come to your circle, you're going clockwise again. So sine 2x, sine becomes cos 2x, multiplied by what you get when you differentiate the bracket, which in this case is just 2x, so that becomes 2. Sine cubed x becomes multiplied by the power, reduce the power by 1, and then multiply by what you get when you differentiate the bracket. So we end up with, and you could write it in a variety of ways. Now what this means is we can integrate cos 2x or sine 2x. We've done it already today. We can do that nice and easily. Sine 2x becomes minus cos 2x divided by 2. Cos 2x becomes sine 2x divided by 2. That's not a problem. We can't integrate sine squared. It's not a nice easy thing that goes back to give you something to do with sine cubed, because this cos x is here. So integrating sine squared x and cos squared x are complicated, and it's those that I really want to focus on. So let's start with sine squared. The way I integrate sine squared x is to use this identity. So I rearrange that identity to say sine squared x equals, and I replace this with what that identity says. That involves a cos 2x, which I can integrate. There's halves in there as well, which make it a little bit of a pain. Have a go, then I'll show you how I do it. It may be we do it the same way. But yeah, focus on this identity, the cos 2x identity that's written in terms of sine. Sorry for those at home, I'm just I often start and stop the video, but I realise this is a bit me, say something, you do something, so it's running for a bit, but you can pause and fast forward as you need to. Okay, can I show you how I do it? And if you've done it differently, then we've probably got the same answer. The way I do it maybe differently to the way you do is this step here. I'm going to write that like that, rather than writing it as a half minus a half cos 2x. And let me explain why. And I perhaps haven't mentioned this approach, which you don't have to use if this confuses you. But okay, so we're rewriting, this isn't integrating yet, we're just rewriting it. We're rewriting as a half of 1 minus cos 2x. If you wrote a half minus a half cos 2x, then you got it absolutely right. But this a half is effectively a coefficient. We know it's going to pass through unchanged. So what we can do, and we can do this not just in this example, but in any situation where you're integrating something where there's a multiplier at the front, we can just sit it out the front there, and we can say, right, I'm going to deal with that at the end. And that's often a strategy which makes things a little bit easier. So that's what I'm going to do. I'm going to sit that out the front there, and then just multiply everything by a half at the end. Now hopefully you can see that we'll all end up with the same answer at the end. But I'm now going to integrate 1, and I'm going to integrate minus cos 2x. Minus cos, when I'm integrating, becomes minus sine divided by. Now I'm going to remember the half. So I've got a half of x minus. Notice I'm not halving my c. Half of a constant is just another constant, so I'm just going to leave it like that. If you chose to write that as a quarter sine 2x, I'd say that's probably even better. So that's integrating sine 2x, sorry, sine squared x. It's a little bit like one of those cardio machines at the gym where you're doing this with your arms and this with your legs, and it's sort of like working out everything in one go. This is a great sort of drill to do because you're using trig identities, integration, a little bit of algebra as well. It's a really, really good, and I would strongly recommend, because sine squared, and we're going to do cos squared in a minute, crop up so often, I would recommend this as a sort of like a regular drill to try. Start by writing out the cos 2x identities and then try and integrate either sine squared or cos squared. Let's do cos squared now. So if I leave that one there for you to make reference to, and see if you can now integrate cos squared x, which obviously is going to involve this identity, isn't it? It's going to involve that identity there. And I'm going to stop the video at this point. Max. So I rearranged my identity, writing cos squared x as a half of cos 2x plus 1. Integrating 1 becomes x. Integrating cos 2x becomes sine 2x divided by 2. A half of that, so you've got a quarter of this plus a half of that plus c, and Bob's your uncle. So let me set you 2 challenges. They're on the sheet, but that we're working on last lesson, but I'll write them up anyway. I reckon I'm now equipped you to answer, and I'm going to leave those 2 up on the board. Question 5 on the sheet, F and G. And these are great questions because they involve a combination of pretty much everything we've done today. Formula book crops up, sine 2x crops up, and there's a bit of sine squared and cos squared. If you come across integrating sine squared or cos squared in the process of this, I just plug the answer in today, but I would encourage you to do a drill. So 5F says integrate 1 plus sine x squared. So the first thing you need to do is grid that out. If we were differentiating, we could do it using the bracket approach, but we can only use the bracket approach if we've got ax plus b in the brackets when we're integrating. So you've got to grid that out first. And then 5g is x squared is sec x minus 10 squared. So for 5f, I gridded it out, gave me 1, 2 lots of sine x and the sine squared x. 1 I can integrate, just becomes x. 2 sine x becomes minus 2 cos x, 2 passes through unchanged, sine x becomes minus cos x. And then you've got your standard sine squared x integration, which I've just plugged in from where we worked it out earlier. A half of x minus sine 2x over 4. And then I just put the two x's together, and just, these two are interchangeable, but just so you know, I wanted to make it clear that that and that mean exactly the same. And can I encourage you to have a go at sec x minus tan x squared, which itself needs to be gridded out. And I'd like to start Monday by just revealing the answer. So if we could, I'd really encourage you to have a go at that. And I've put on class charts just a reminder about, we've done a lot of integration this week. So you've got numerical methods, which I'm hoping to do on Monday period 6, the first lesson on it. So we'll have a first the daytime lesson on integration, and then the afternoon lesson on numerical methods. You've got past paper practice, but then in the middle you've got finishing off and mopping up anything that you start in class and you don't finish. And there's plenty of stuff from that in the textbook that we can do.